this video, we will see about an Mosfet operation, input characteristics and output characteristics. So basically, field effect transistor. Field effect transistor is nothing but an voltage control device. So here, for different applied input voltage, the output current varies. So now let us take an device, go to symbol, and please select an NMOS. So here in Mosfet we have two Mosfets, an NMOS and PMOS. So now we will take an NMOSFET and then we will study the characteristics of the NMOS. So here to study the NMOS characteristics, now I have taken NMOS and then take an voltage source here. So give the input voltage, have input voltage source and have an output voltage source, and then through wires you can connect the voltage source. So this is my gate terminal and this is my drain terminal and this is my source terminal. So here we can give the inputs. So I have connected. I should give the names for all the terminals. So now let me take a terminal as a gate. It's a gate terminal. I want to move this. So to give a gate terminal, we have three terminals in Mosfet: gate, drain and source. So this is my gate terminal, and then another terminal is called drain. This is my drain terminal, and then another terminal is called source. This is my source terminal. And then so the input we are applying between VGS, so I can edit this V1 as a VGS. And then output we are going to see between the drain and source, since source is common for both input side and output side. So VGS is input and VDS is the output. So here it is VDS. So I am going to give an input voltage as a 5 volts and then VDS also 5 volts. Now let us do a simulation. At first we will study the input characteristics. So we should plot an ID current for the input VGS voltage and then for different constants of VDS. So what I'm going to do is go to simulate edit simulation command and go to DC sweep, select your first voltage source to sweep. We are going to see for input. So you select your first source as a VGS, and the type of sweep we want to do is linear, and start value is 0 and stop value is 5. Why I am giving 5 means here the maximum voltage I have given is 5. If you have given 10, you can change accordingly. The increments will be 1. The second source for VDS. Why VDS means for different constant voltage of VDS, we will study the VGS versus ID characteristics. So 0 and 5 and increment value is 1. We can keep it here. And then you can go for simulate, run it. Yeah, we didn't connect a ground, so here we can give a ground. I have missed a ground, so now go to run. So here and you can see. So we are going to check for the characteristics of an ID, right? So add traces ID of M1. So here we can see from 0 to 5 it has been gone for sweep. So for 0 to 5 it has gone for sweep. So here the x-axis is VGS. We are plotting for input characteristics. So the x-axis is VGS. We can see here VGS, and then the y-axis is ID, drain current. So we can see for different voltages. So you can see here, go to select steps. So for different VDS value, we have got the characteristics between the VGS and ID. So if you want to do for VDS is equal to 2 means what is the characteristics? You can see this is the corresponding ID characteristics for the VDS is equal to 2. Suppose for example, if you have an VDS is equal to 3, what is the characteristics? So this is the corresponding characteristics, input characteristics for the MOSFET. So now let us do for an output characteristics. So go to simulate once again. Go to simulate. Go to edit simulation command. So the first source here we should choose VDS because we are going to plot now output characteristics. The output characteristics VDS versus ID. The second source is the VGS for different constant values of VGS. So you can see here it has been changed. So now we can go for a simulation. So you can see here we have gotten VGS and this is VDS. The input means VGS versus ID. The output means VDS versus ID. VDS versus ID. So now you can see here view, add traces, go to add traces. I'm going to plot an ID of an M1. So here this is a corresponding output characteristics for the MOSFET. So the x-axis is VDS and y-axis is ID for different VGS. You can select the steps over here, give view, select steps for different VGS we have plotted. Suppose for example for VGS is equal to 2, if you want to see the output characteristics, we can see it over here. So it is in the saturation region, it is in the non-saturation region, and then to go for saturates above 2 volts. So likewise we can see for all the different VGS. Select all and we can see for all the VGS. So this is how you can study the MOSFET characteristics for the input and output characteristics. Thank you for watching.